Hi, everybody. Thank you for joining us today. We're going to wait for a few more people to jump on, and then we'll get started. Hey, it looks like we have a great group here so far. So thank you again for attending our webinar today. I'd like to start out by introducing Bob Tynan, our Chief Commercial Officer for RocNet Supply. And he's going to be our first speaker and get you started today.
Great. Thanks, Susan. All right. Thanks, everybody. Thanks for attending. We do appreciate it. The title of the session is Debunking the Myths of Access Solution, Alternative Access Options Providing 10 Gig Throughput for Cable Providers. So my name is Bob Tynan. I'm Chief Commercial Officer for RocNet Supply. I'm going to spend about 5 minutes talking about the focus of the solution of this webinar, as well as a couple slides on RocNet as a company. And then I'll pitch it over to Vijay. We have two people from our partner Vecima on the call. Vijay will talk about 10 gig EPON and that solution, and Scott Raaf will discuss the pros and cons and benefits of Remote MAC-PHY. So with that, once you forward, there you go. So real quickly for RocNet, I won't take too much time on this, but it kind of leads into why we're having this conversation. So Rochester Network Supply is a value-added reseller in the networking space, predominantly focused on service providers. The company was incorporated in 2014, and we really cut our teeth in secondary market networking solutions focused on cable operators. So that green market section in the middle is something that we started the company with, and we still do today. So we can still sell and monetize, let's call it pre-owned networking equipment from core to access to CPE for our customer base. But what started happening about 5 or 6 years ago is we also started to resell new product solutions because we had customers asking for it. So we have really curated and are reselling a number of different solutions from core to CPE across multiple different vendors. Vecima is a recent partner for us, and they've really identified some new technologies that we really hadn't explored in the past, but are really purpose-built for the cable operator and for the right opportunity and the right customer, I think are somewhat compelling. You know, the last thing that RocNet brings to market is a series of managed services. So we do support pre-sale engineering, post-sale engineering, and logistics services solutions. And as a result, you know, we talk to a lot of customers and we get a lot of feedback. And again, that's what really identified 10 gig EPON and MAC-PHY as, well, I'll call it two non-standard solutions for a lot of our cable customers, because they are purpose-built for cable operators, that may provide some opportunities for you that maybe you heard some different information about or didn't quite have the right information. And that's what this is about, is to get you dangerous and educate you on what they do and what they don't do. Next slide. So this is a graphic. This articulates RocNet. So again, we start with our customers at the design part of their process, work through tests, deployment, support, and end of use. And as you can see from a product standpoint, design is most of the time some of our new product solution partners. And as those products are in the field for a while, additional equipment is needed, or it gets to end of use, that's where we start to work with our customers from a secondary market, whether supplying products they can't get at a better price or helping them monetize equipment that is now end of use for them. The items on the right-hand side are a number of services that we offer while we're working with our customers. Everything from engineering support. Remote lab is one of the new things that we've been working on recently, which is building purpose-built, nailed-up lab solutions with remote access for customers who either don't have that today or have something, but they want to have it a little bit more security than what they currently have in their network. And then we work all the way to the end with asset management and consignment solutions. So, that's the end of the sales pitch. Please contact us if any of these solutions seem to meet your needs, and we'd love to work with you and support you. Next slide. Okay, so we probably have about 300 buying customers in any given year, and there's probably another 1,000 customers, predominantly in North America, that we talk to. And especially on the cable side, and my career started in cable at Scientific Atlanta, a couple of stints at Cisco, Casa Systems. So I've been in the space for a little over 20 years. We talk to a lot of customers on a regular basis based on what they need in their portfolio. And some of the themes are relatively consistent. The one we hear all the time is, which is no surprise, competition is fierce, bandwidth is king. I don't have to show the chart that everybody sees of bandwidth going up and to the right. It's not slowing down. There's government money available. There's a lot of overbuilders from a fiber standpoint. And so we want to help, especially our cable customers, be able to keep up and be able to build their network with an eye towards the end game, which is traditionally an all fiber network when and if it makes sense for you. A lot of our customers are smaller, so solutions that are easy to deploy and manage are very important. Concept like virtualization has a lot of moving parts and is less manageable or new to a lot of our customers. So that's an example of things that are a little bit more complicated. Customers, if they spend money, really want to minimize their regrettable spend. It's not always possible, but hey, having a device in the network that has a future, that has longevity, that can scale, and you're not re-spending money to replace what you already have, is always important, because nobody's OpEx and CapEx seems to be going up with the growth. It seems to be flat or sometimes even going in the opposite direction. And then, like I mentioned before, providing options with an eye towards fiber to the home. May not be today, may not be tomorrow, but either fiber to the home options that are fit more and managed better within a cable network, or options in the network that get you closer to an all fiber solution, is something that everybody is interested in and appeals to. So these two solutions that you're going to hear about today seem to fit a lot of these requirements and a lot of these needs. And we're excited to hand the ball over and let Vijay and Scott give you a few more details. Oh, one other thing. So please, no, stop with that one. Switch over. Please, if you have any questions, I think you can put those in the chat. If you can hold those to the end of the discussion, we'll address those in the last 10 minutes. But again, thank you for attending. We really appreciate it. And with that, I'll hand it over.
Thanks, Bob. We appreciate it, and appreciate the opportunity to you as our partner with RocNet, and the opportunity to present here today our products and solutions. And so hi, I'm Vijay Raman. I'm VP of Product Management for Vecima's fiber access product portfolio. And I'll walk you through options, we believe is a great option for fiber to the home, and that's 10 gig EPON and with DPoE-based provisioning solutions. And so before I walk through some of those specifics, I thought I'd start with a couple of highlights, just a little bit about Vecima as a company. So Vecima been around for about 35 years, a very R&D centric company. Worldwide offices, worldwide R&D, with the focus, a laser-like focus on providing solutions to cable operators, right? And so essentially we've got three main business units. Scott and I are in the video and broadband solution business unit, and this business unit is essentially fueling, or has had the most to do in terms of fueling the growth, as you see below, of Vecima, primarily over the last 3 years. So if you look at specifically at our portfolio, kind of have three major product segments, and once again, this is purpose-built solutions and a portfolio for cable operators. And so we have a media scale product lines. These are focused really around QAM to IP video based products. There's Terrace products, which are commercial video products targeted at enterprises and verticals like hospitality, as an example. And then the biggest focus is the Entra product line and family. And so this is where we have the DAA nodes, platforms, as well as the fiber to the home products, fiber to the premise products with remote OLTs, as well as PON shells. And so really, if you take a step forward and kind of give a broader view of sort of our value proposition and our solution set, it starts with providing cable operators a unified access solution set. So essentially starting with common control with our unified access controller that has a set of core functions that manages a variety of platforms and has a variety of ways to manage those platforms, either through CLI or northbound interfaces. And so as a result of that common control, we have this ability to go with common routing and switching and allow our customers to pick any routing and switching platform that they need and can support any service up to 10 gigabits across any medium, whether it's HFC coax or fiber. And in these areas, we are currently in a strong market share leadership position by Deloro in remote OLTs and remote MAC-PHYs. And so I'm going to focus really down here on the fiber access portfolio and specifically around 10 gig EPON solutions with DOCSIS provisioning. So really, if you look at operators, in terms of today, legacy-based architectures, CCAP cores, analog nodes, analog fiber-based solutions, and we offer a variety of paths to get customers to 10 gigabit solutions. They can take incremental paths with our PHY, our MAC-PHY, through a vCore, or go directly to 10 gig PON-based solutions. So if you look at a PON network, and specifically today, what are some of the key components? Kind of looking at it from the core or the aggregation all the way to the access, right? So essentially, as I mentioned before, you can use any edge router, any set of SYN aggregation switches. And then if you look at the platforms that we bring into the market, it's OLTs. And key for us is working with a family or any set of different ONU partners that we have to build these 10 gig EPON DPoE-based solutions that allow you to get to 10 gigabits. So this is sort of just a general view of some of the key topology, as well as some of the key vocabulary you hear in terms of deploying out a PON network. So there's a few different types of PON types that I wanted to walk through. So starting really at the beginning of the 2000s with GPON, and the throughputs that it offers, 2.5 gig down, 1 up. Basically, you can do split ratios. It's a point to multi-point technology PON is, with a primary use case of residential. You still see many customers out there who do GPON. Then 10 gig EPON, right? So basically GPON, XGS, some of these other PON types driven by ITU, and then IEEE was the ones driving the 10 gig EPON standards. And so with 10 gig EPON, downstream and upstream rates, same as for XGS PON, 10 gigs up, 10 gigs down, and with a very similar set of primary use cases. NG-PON 2 really targeted for one large service provider, telco out there, and then sort of next gen 25 gig and 50 gig PON, right? So there are some vendors out there who do have 25 gig PON products in the market today, as well as some vendors with 50 gig PON. Really though, if you look at kind of what's going to move in volume and scale over the next several years and through this decade, likely into the next decade, are going to be the 10 gig PON based solutions. And so specifically for cable and cable operators, DPoE with 10 gig EPON, GPON, XGS-PON are really the two primary flavors of PON that we see and you see in the market and could expect to see at scale and volume really over the next 10 plus years. So what's the differences between these two primary types? I mean, obviously GPON, XGS-PON, the bigger part of the market, but in cable and cable operators, and if you look at subscribers, cable subscribers who do fiber to the premise, 10 gig EPON with DPoE has already a big portion of market share. And so if you're going to compare the two, the throughput, the usable throughput, is the same, right? So basically, these are 10 gig PON technologies, but due to overhead, things like FEC, your usable throughput is about 8.7 gigs of throughput. GPON, XGS-PON offers a path from GPON through a couple of combo PON options. And typically in most deployments that we see in here, they're primarily bookended. So you have a single vendor in most cases for OLTs and ONUs. Now with 10 gig EPON, this technology, driven by IEEE, but with specifically standards on interoperability, was driven by cable labs. And with cable labs, very stringent requirements and very stringent, rigorous standards around interoperability, you'll see a lot more multi-vendor environments. And really driven, the way it was driven was really around DOCSIS provisioning. Right, so DOCSIS provisioning and the ability to do DOCSIS provisioning is probably the main benefit for cable operators to do 10 gig EPON. And so how does that work and how is that driven, right? And so literally, if you look at this diagram, you see all the DOCSIS OSS servers for provisioning, management, troubleshooting, and those are leveraged into the traditional cable operator network. With 10 gig EPON, you simply have to, you're essentially leveraging that entire backend provisioning system, not requiring a new management system, but essentially leveraging that whole backend system and essentially rolling out services, 10 gig services, symmetrical 10 gig services to your end user and your customers. And since Cable Labs drove a very, as I mentioned earlier, rigorous standards, you have a lot of flexibility in terms of what OLT vendors you select, as well as the variety of different ONU vendors out there. And so what that allows, it allows operators to kind of selectively pick their OLT vendor and their ONU vendor of choice independently. And so essentially with DPoE, the PON system looks a lot and feels a lot like bringing up a DOCSIS-based CMTS system. And so that commonality, that similarity drives service agility and the ability to roll out fiber to the premise services faster, especially if you're competing with telcos who are trying to overbuild you. If you look at the applications, the use cases, they're essentially the same for GPON, XGS-PON with DPoE and 10 gig EPON, right? So essentially residential fiber to the premise, you can do business-based services. Since we have remote OLTs, you have the ability to deploy these in rural areas and reach customers as high as 80 to 100 kilometers away from a head end or a hub office. And so as a result, with DOCSIS provisioning, you have the ability to, in an accelerated way, roll out these services and to do it in a simpler fashion. So what does a solution deployment actually look like? So you have the Entra access controller, which is essentially the linchpin of this architecture with standards-based Cable Lab CCAP interfaces, essentially configuring, pushing down the configurations onto the nodes or the shelf. You can deploy this as a layer 2 network, VLAN-based architecture with layer 3 management, and essentially support a variety of different third-party ONU types. Just a couple of quick points on our platform. So we have different platforms that support different capacities in terms of fiber to the home premises that you serve or subscribers to serve. So larger chassis-based platforms, remote OLT platforms that you can deploy, further out into the rural network, and as a result, reach those subscribers and This product is recently BEAD compliant, BABA compliant, and as a result, eligible for all that the funding as well as the EXS 1610. So this is a shelf-based product. Supports up to over 1,000 subscribers. A couple of different deployment scenarios I've mentioned, and then the intra-common software for the SF4X and the 1610 are the same, and that also can deploy in conjunction with Remote MAC-PHY. So in kind of conclusion and wrapping up, we have a set of key features for our platforms, really around its layer 2 management, DOCSIS-based provisioning that simplifies the deployment and accelerates services, and the ability with the remote OLT that allows you to deploy the product at much further distances. Why Vecima? Why 10G EPON and DPoE? Just a few important highlights to conclude this segment of the presentation. Faster time to service, leveraging that back end that you already have with rolling out DOCSIS-based services with the CMTS. Lower TCO because you have, due to Cable Labs standards, driving very specific multi-vendor interop, you have this ability to roll out with any OLT and any number of ONUs. And so from a Vecima standpoint, we interoperate with all the major 10G EPON ONUs out there. So no concern from a customer's part or cable MSO's part to select the ONU to work with. Portfolio of products, remote OLTs allows you to reach further customers, temperature hardened shelves for higher capacity configurations with investment protection, and as a result of our single unified common control, unified access-based solutions, you can deploy DPU or 10G EPON or fiber to the home services, and then do that in conjunction with the Remote MAC-PHY. And then as a result, you can selectively determine what technology you want to deploy in any particular market to support those subscriber needs to scale. So those are the highlights on 10G EPON DPoE. At this point, I'll hand it off to my colleague, Scott Raaf, who will go over HFC-based architectures and solutions. Scott, I think you might be on mute.
Thank you, Vijay. Hey, Bob, I'd like to thank you for and RocNet for being a valued Vecima partner and for bringing our solutions to your customer base. So I'm Scott Raaf. I'm Vice President of Cable Access for Product Management at Vecima, and I'm responsible for our Remote PHY and our Remote MAC-PHY solution sets. And today, I'm going to talk about the specifically the HFC DAA architectures, and and very specifically virtual CMTS, Remote PHY, and MAC-PHY, Remote MAC-PHY solution sets. So, we had this slide up earlier. There are multiple, I would say, paths for the evolution of your networks, and not every customer is going to be taking every step. And it really, what we're trying to do is help you make the right decisions for what's right for your network. So I'm going to start with just maybe a little some basics here about what's the difference between a centralized HFC architecture versus a distributed one. In a centralized architecture, you have a purpose-built hardware platform that provides the CMTS functionality, and if that CMTS also includes video functionality, it's called a CCAP. And then the link between, so the output of the CMTS or the CCAP is RF, and then that RF is transported over the network using analog optics to an optical node where it is, it goes from the optical domain back to the RF domain. In a distributed architecture, the PHY from the CMTS is separated, and the PHY or the MAC and PHY are separated and are relocated to the node. And then because the PHY has been removed from the CMTS, it becomes IP in and IP out, and enables virtualization and commercial off-the-shelf hardware versus using purpose-built hardware. Then and because the output of the virtual CMTS or the CCAP core is digital and it's IP, then the analog transport layer is replaced with digital optics. Now, when you look at I would say a traditional HFC integrated CMTS architecture, the CMTS is located in a head-end or hub. It needs to be located fairly close to the endpoints, to where the modems are. And then analog optics are used to go to the remote, to an analog node. And at that point, there is a cascade of amplifiers that feed the network. And when you look at the noise contributions that comes from this, the analog optics are contribute greatly to the noise figure within the network. And then every time you go through a kind of an amplification step, you're contributing more noise, because you're essentially, I would say you get a bit of degradation in every one of those amplification steps. So at the end of the day, you are limited in the modulation profiles that you can use in the network because of the noise figure. When you move to a distributed access architecture, again, the analog optics are removed from the network, so you get to remove that cost from the solution set, and digital optics replace that analog link. And then either the PHY or the MAC and PHY are relocated to the node. In what's called and if you drop this into an existing, I would say, legacy network, and you keep the amplifiers in the network, that's what's referred to as an N+X network. But because you remove the analog optics from the network, you greatly improve the noise figure of the network, and you're able to basically improve or use higher order modulation schemes that are available in DOCSIS 3.1 to get more bandwidth down that same pipe that normally would have, would have been limited with. Now, if you look at what's referred to as an N+0 network, and it's the same as an N+X in a DAA network. And if you drive the fiber deeper into the network so that the node is able to directly reach the homes, that's what's referred as an N+0 network. And because you got rid of both the analog optics in the network as well as all the amplification steps, you end up with a very pristine plant. And many instances, we have customers that are running 4096 QAM in the downstream in their networks and 1024 or higher in the upstream, and being able to get significantly more bandwidth through that network. The other thing is, because you are driving, relocating that node deeper into the network, by nature, your service group has been reduced in size, and you have more bandwidth available to each of those homes within that service group. Okay. Now, if we look at the major differences between Remote PHY and MAC-PHY, we'll start with Remote MAC-PHY. Number one, the MAC and the PHY are located in the node. So essentially the node becomes a miniature CMTS. And then, so there is no separation of the DOCSIS MAC and PHY within the network. Therefore, the scheduler is located in the node, and there's no digital timing synchronization required between the core and the node. Okay, and in a Remote MAC-PHY deployment, the controller is essentially the MAC manager, which is a control plane engine, and the data plane does not flow to through the MAC manager. So because the timing There's no timing required in the network because the schedulers within the node, you can locate that MAC manager anywhere you want to. So it could be in the head end, it can be in the hub, or in many instances, it goes to a data center. So there's literally no data, I would say length separation, distance separation, or hop separation that you have to maintain between a MAC manager and a remote MAC-PHY node. The and because the MAC manager is just a control plane, if you lose the connection to the MAC manager to the node, data services continue to flow, and fundamentally you're able to go repair your MAC manager connectivity, and there's no interruption of service, but you do lose the ability to provision new services during that time, as well as you lose monitoring of those nodes in the network. In Remote PHY, the DOCSIS function is separated into a MAC. I'm sorry. The DOCSIS functionality remains in the CCAP core, and the node has the PHY. So there is a separation of MAC and scheduler from the PHY. R-PHY pseudowires are used to basically create tunnels where the data flows go between the CCAP core and the remote PHY node. And since the DOCSIS scheduler is in the CCAP core, you have to have timing synchronization between the core and the node. And that adds a layer of complexity to the network, and it adds a layer of cost in your switching network, because now you have to have switches that are timing capable, are capable of distributing timing. And so as a result, you have a limited ability to separate the CCAP core and the node. Now, CMTS vendors have developed a variety of techniques in overcoming this inherent, I would say, limitation. And so they are able to, I would say, increase the distance between the CCAP core and the remote PHY node. But when you have services that require a request grant cycle, these are relying on having an uncongested upstream and to be able to reliably sustain high transfer rates. So you have to be very careful when you designing your network planning capacity to make sure that these techniques for extending the distance actually are realizable in your network. And there are some, I would say, efforts that have been undertaken to maybe separate the management function from the data plane within the CCAP core, and so that you could relocate those to a data center. But then fundamentally you're adding another element within the network and another layer of capacity of complexity. Okay, if you look at the space and power comparisons between a big iron integrated CCAP solution versus a CCAP core plus remote PHY that's still based on big iron versus a virtual CMTS with an R-PHY node versus a remote MAC-PHY MAC manager with a MAC-PHY node. The clear winner from a power and space perspective in the head end and hub is remote MAC-PHY. And the reason for that is because you are moving that processing to the node. So you're moving the power consumption and the cooling from the hub to the node. And in the hub or in the node, cooling is free because they're passively cooled using the environment. So I think another key distinction here is that if you look at how many rack units a virtual CMTS plus remote PHY solution is versus a CCAP core remote PHY solution, a physical core solution versus plus or remote PHY node, you actually see that virtual CMTS is a more efficient solution than a hardware implementation of a remote PHY CCAP core. And that's because all of the hardware CCAP platforms that are out today were designed 5 to 7 years ago. And there's been some vast, I would say, improvements in the server processing capabilities. And so fundamentally commercially off-the-shelf processing platforms have more processing capability per rack unit than these purpose-built hardware platforms that were made 5 to 7 years ago. So, when you're looking at the, I would say total cost of ownership, you really need to consider how much space you're using, because real estate's not free in a head-end or hub. You need to look at what the power consumption is and what the cooling capacities are required. Okay. So if we look at what the bandwidth is, capabilities of these platforms are by technology, integrated CMTS, I would say maxes out around 4 gigabits per second downstream and about 1.5 in the upstream. There are some of the CMTS, integrated CMTS vendors have been, I would say, evolving their platforms. But at the end of the day, they're limited by hardware and how much processing they have in these platforms that were built, originally designed 5 to 7 years ago. If you look at a Remote PHY solution set based on a hardware big iron Remote PHY platform with a Remote PHY node, you essentially get about the same capacities because the technologies are the same. When you move to virtual CCAP, fundamentally your DOCSIS capabilities, your MAC capabilities are now virtualized and running on a server. And so, you can apply as many resources as you need to get the service that you need within the spectrum that you have available. So with a virtual CCAP solution, you can get up to, and the PHYs that exist today for Remote PHY solutions, DOCSIS 3.1 MAC Remote PHY solutions, you can get about 8.5 gigabits per second downstream. That's based on 5 OFDMs. And you can get about 1.5 gigabits per second, and that's based on 2 OFDMAs in the upstream using a high split. But interestingly enough, if you look at that compared to Remote MAC-PHY, the capabilities are the same. And that's because the PHY is the same. And then it really comes down to how much processing is available to drive that PHY. And then as we evolve to DOCSIS 4.0, and I'm going to use the example of ESD because it's a little bit easier to do the calculations on when you have deterministic downstream and upstream bandwidth or spectrum. In DOCSIS 4.0, 6 or more OFDMs are available, and which results in a downstream throughput of 11.5 gigabits per second. And if you're doing an expanded upstream at 396 megahertz, you can fit 4 OFDMAs, which gives upstream about 3.1. One thing to note is that while the DOCSIS 3.1 has the capability of 8.5 gig in the downstream, that capability is only unlocked if you have a DOCSIS 4.0 modem, or if you have, one of the, I would say, deploy one of the recently announced DOCSIS 3.1 turbo modems that supports 4 to 5 OFDMs in the downstream. Okay, now if we look at some of the advantages and disadvantages against the two different technologies here. So if we start with Remote MAC-PHY and the advantages. Number one, it is simpler to deploy. It is the MAC manager is control plane only. There is no cloud data plane to manage. So fundamentally, it's technologies that most of our customers have available and in their, I would say, in their companies today. And next, if we look, there's no timing required between the core and the node. That number one, that simplifies the overall implementation. You don't have to design timing into the network, and you don't have the cost of supporting timing in your network. And frankly, one of the biggest, I would say, contributors to downtime in a Remote PHY network is often the loss of clock and exceeding the holdover time that's capabilities of the node in that situation. With Remote MAC-PHY, you can locate the MAC manager core anywhere you want in your network. So you can put it into a hub, a head end, and most of our customers put it into a data center. There's lower space and power required in your hub because fundamentally you're shifting that space and power to the network. There's lower core cost because again, there is no data plane processing. The node operates, services continue to flow if the core connection is lost, and you can take advantage of the passive cooling of the MAC within the node. Now, if you look at Remote PHY and the advantages, well, first, because you're not running a MAC within the node, you end up with slightly lower node and node power consumption, but this really isn't significant. It really comes down to extra memory within the node. Next is there is a slightly lower cost to the node to the lack of the, I would say, I covered that one, but the MAC scales independently of the node hardware. So if you're concerned about, being able to migrate your network towards DOCSIS 4.0, I would say the head-end contribution of that scales independently of the node. But the other thing is that the RPDs that exist today are, I would say, DOCSIS 3.1 RPDs. And literally, if you're going to move to DOCSIS 4.0, you have to replace the RPD in the network anyway. So, that kind of mitigates the independent scaling of the MAC, because you'll have an opportunity to insert a new MAC if you make the decision to go DOCSIS 4.0, and if DOCSIS 4.0 solution sets are available to, outside of, I would say, development agreements with the silicon vendors. Now, if you look at the disadvantages of Remote MAC-PHY, the biggest one is probably the lack of MAC manager interop. There were efforts within Cable Labs to develop the flexible MAC architecture. And the whole purpose of FMA was to be able to standardize interfaces in a Remote MAC-PHY world between the core being the MAC manager and the node. And since the industry, I would say some of the larger MSOs in the industry have pivoted towards Remote PHY, those efforts have paused. But that can be overcome, because really there's no reason for one vendor's MAC manager to manage somebody else's node, because the MAC managers are very lightweight. They can be deployed in VMs, and literally they're very low cost. And it's not that big of a step if you want two vendors of Remote MAC-PHY in your network to deploy two different MAC managers. There is slightly higher node cost because there's a little bit more, but I mean, this is less than 10% typically. Other thing you have to take into account is what the licensing component of a virtual CMTS is. Whereas when you buy a Remote MAC-PHY node, you get full spectrum capabilities for what you paid for. There is slightly higher node power consumption, but if you look at that most of these nodes are either analog nodes that are being upgraded to Remote MAC-PHY. If you look at what the power consumption is of these traditional analog nodes, it's actually about the same as what the equivalent Remote MAC-PHY solution is. And then, the thing here is, talking about MAC scalability, you purchase your MAC capacity up front, so you know what you're getting. And the question is, how long does that MAC, live in your network? How long does 8.5 gigabits of downstream buy you? And, and when you make that decision to move up from that solution set, are you going to, you want options there. You don't want to be locked into a single, I would say, technology. And from a Vecima perspective, we make all of our nodes to support all technologies, meaning you can migrate them towards, you can migrate towards Remote MAC-PHY to Remote PHY if that's the decision you want to go, or you can even migrate them to PON. Okay. If you look at some of the disadvantages on Remote PHY, number one, especially if you're dealing with a virtual CMTS, it's more complicated to deploy. All of the virtual CMTSs today are on a cloud native platform, and you either have to pay the vendor to manage that for you, or you have to develop that capability to manage it internally yourself. There is greater core cost due to the MAC and the data plane processing that occurs within the virtual CMTS. It drives a lot higher space and power requirements in the hub and cooling. You have to implement the DTI synchronization between the virtual CMTS and the nodes. And again, there are some distance limitations that have to be considered, and network planning that has to be considered when you want to locate that CCAP core, more than a couple hundred kilometers from the node. Now, if we, refreshing I would say our view of, Vecima's view of unified access. As Vijay alluded, we have the common control with our unified access controller. And when you deploy this controller, it has all of the interfaces in it today to drop into a DOCSIS provisioning network. So everything, all of the, I would say, interfaces that you have today on an integrated CMTS exist on the unified access controller. Then you get to pick which solution that you want to deploy to the field. You can deploy Remote MAC-PHY, you can deploy Remote OLT, or you can deploy them both on the same common control infrastructure. Okay, and looking into the specifics of Remote MAC-PHY node solution set, we have the SC1D2. That is a 4-port compact node. It's 1x2 capable. We have the SC2D4, which is a 2x2 Remote MAC-PHY node. Now, the SC1D2 today is shipping with 1.2 gig ports. Very shortly, we will be shipping that with 1.8 gig ports. Our SC2D3 and the SC2D4, or SC2D4 ships today with 1.8 gig ports. We support all of the I would say standards-based splits in the networks. Most of the networks today, as a drop-in, are being deployed with low split, but more and more we're seeing mid-split and now high split being deployed. All of our Remote MAC-PHY nodes are full spectrum capable. You can drive the entire 1.2 gig spectrum with either DOCSIS 3.0 QAMs or a combination of DOCSIS 3.0 and DOCSIS 3.1. Today, the SC1D2s can support up to 192 megahertz OFDMs in the downstream. Today, the SC2D4 supports 2 times 192, but we continually evolve and develop our MAC and our node platforms. And so we will be, I would say, introducing some, I would say, increased scale on our SC2D4 platform very shortly. We have full spectrum upstream as well. And all of our nodes support local RF injection analog optical overlay for those customers that require that for either doing things like in MDU situations, putting in local cameras, or for customers that still have analog on the network, you can keep that tier there and add the digital tier on top of it. And then all of our nodes are IP68 with a variety of mounting options. Now, if we look at, again, why Vecima Remote MAC-PHY, number one, Vecima is 100% focused on the cable and fiber access markets. We are investing more than probably any other vendor in this space today. And that's why we've been increasing our market share year over year. If you look specifically to our MAC-PHY solution set, it is substantially less complex than a virtual CMTS. Therefore, you get much faster deployment. It plugs into the existing network. Our access controller, is designed to plug into a DOCSIS provisioning network and monitoring network today. So it's easy to deploy. And it supports an overlay model because you can locate that MAC manager anywhere in the network. Unlimited distance between the controller and node. Less head-end space, power, cooling, and server costs. And again, you have the opportunity to have a single controller management entity for both your Remote MAC-PHY as well as your PON deployments. So I think at this point, I will hand it back to Bob.
Awesome. Thanks, Scott. Well, hopefully that was helpful for everybody. Again, these are technologies that aren't talked about as often as like a VC cap, but I think have some really compelling applications for our cable customers. I want to put, before we get to any kind of Q&A, I want to put a plug in here as well. So we are working with Vecima and our other partners to offer architectural bundles for the two solutions that you saw today, as well as a few others, including VCCAP with bring your own node, and two different 10 gig EPON options. And Vecima approached RocNet because they have some really critical pieces of that architecture. And then RocNet, through a number of our different partners, really can kind of complete that core to CPE bundle. So those bundles are in process right now. In the next few weeks, there will be specifics going out to the marketplace in terms of pricing, what's included, and then other options that could be attached or taken out of the bundle. So we're trying to design this to be able to target the smaller down market cable operators and be able to have these solutions kind of put together in a one-stop shop, where RocNet with our engineering team can help from a support, configuration, and deployment standpoint. So look forward to working with any of you out there who are interested. If you are interested, the email is bundles@rocnetsupply.com. And love to have that conversation about whether these solutions meet your needs. So with that, I think we are at the Q&A section. Are there any questions, Susan, that you want us to address, or you want the team to address?
We do have a couple. So from a DAA standpoint, how do you support video in a DAA network?
Yeah, I'll take that one. So all of our solutions are designed to work with DAA compliant video cores. And so there's a number of those that are on the market today, but many of the operators that are migrating their network already have MPEG video QAMs. And they want to sweat those assets. And so we actually have some what we call video engine adapters that allow you to basically turn your existing MPEG QAMs into DAA compliant video engines that will work in any vendor's DAA deployments.
Got it. We have another one. How do you monitor RPDs in a DAA network? Anyone want to jump on that one?
Did you see, what was that? Could you repeat that question, please?
Sure. It's how do you monitor RPDs in a DAA network?
Oh, how do you manage RPDs? And I thought you said remote OLT. Thank you. Fundamentally, the Vecima prides themselves on being developing standard-based solutions. So the way that you get there's two ways to get information from that RPD. You can either do it through the CCAP core, or you can go to the RPD directly. If you use the CCAP core, you have to be kind of careful about how much you monitor, because there could be hundreds of, maybe thousands of RPDs connected, hundreds definitely connected to a CCAP core, and monitoring can have a kind of a high CPU load. Alternatively, there are monitoring solutions that reach out and directly pull data from the RPDs using the standards-based TLVs. And there's a few different solutions in the network, and Vecima has one that we refer to as Remote MAC-PHY monitor that provides some really good insights into the performance and health of the network.
Awesome. Thank you, Scott. Let's see, we had one come in. What are the major challenges faced by cable operators when adopting fiber to the home in North America?
Thanks, Susan. I'll take that one. So that's a great question, Syed, because I think you may notice that you look at worldwide, there's a number of countries out there that have adopted fiber to the home a lot faster than here in the US and in North America in general. And I think if you look at over the years, the technology has been available, the various PON technologies, throughout the 2000s. The challenge previously has been the cost, right? So the cost and that impact. And I think what's different now over the last year or so, or a couple of years, and we believe, the market believes, you're going to see a substantial acceleration in getting fiber to the home here over the next 10 years, is the federal government in the United States is now subsidizing a lot of those costs. So basically through RDOF, BEAD, and these are programs where the federal government is essentially funding the rollout of fiber. And so essentially where it's at is, they are providing monies to the various state broadband offices, and those state broadband offices are in turn rolling out the ability to have RFPs and get fiber trenched and get fiber services deployed. With that, I believe I've seen a goal of in the early 2030s to get nearly all potential users or potential subscribers rolled out with fiber. So I think that is the big difference now versus, I would say, 10, 15 years ago. Well, it's always been the holy grail to get to fiber, but at the end of the day, the cost to add per subscriber was the challenge. So now you'll see, in our view, that moving faster with that federal government monies out there.
Yeah, there's other things too. I mean, the back office provisioning and management is something that the 10G EPON addresses. But if an operator is going with a GPON or XGS-PON, most vendors don't have a integrated DOCSIS provisioning system, so that you have a swivel chair approach. There's ways to work around it, but it's not really clean. I know Cable Labs is looking at potentially addressing that.
Yes.
And then the other thing is, with that approach, the CPEs and the OLTs are bookended from a vendor standpoint, and it's not an open network. So, for instance, if you want to go with a Calyx OLT and you want to use somebody else's ONT, you have to make sure that work's been done to integrate the two. There are some vendors. We actually have a product from a company called Halney that uses adaptive OMCI software that allows that to happen, but there's no standards body right now that's driving that. So depending on your inventory and flexibility and what you're looking for, sometimes that's a hurdle as well.
Wonderful. So we are coming up on the top of the hour. I think that's all the questions that we have for now. So thank you all for joining us for today's webinar. Thank you, Vijay, Scott, Bob, for sharing your insight with us. We did record this meeting. We'll be sending it out in an email, so you'll see that soon. And again, thank you so much for your interest.
Thank you.
Thanks, everybody.
you.
Have a great rest
Take
of your
care.
day. Bye, everybody.